Hi, it's Tim. Welcome to the channel. We're used to seeing single board computers like this Raspberry Pi or this Pi Zero and controllers like this Arduino Uno or Arduino Mega. And they used to control things like machinery or LED panels. Or we use them in our retro computers for driving displays or emulating floppy disks or to act as co-processors and so on. But this is a different beast. Yes, it's still a single board computer. It has all the GPIO pins that we expect to see, but at its heart is a Z80 processor and it runs BBC Basic and it comes as a kit. Here I've got a whole bunch of pieces to solder onto it. This is the Agon Lite. Let's take a look. PCBWay delivers high-quality printed circuit boards with a 24-hour turnaround, starting from just $5 for 10 boards. Choose from a large selection of shared projects where the boards are already designed, or upload your own Gerber files through the easy-to-use web interface. And it doesn't stop there. PCBWay also do flex PCBs, advanced PCBs, assembly, 3D printing, CNC and more. They can even supply solder paste stencils for your SMD work. Check them out, www.pcbway.com. There are two versions of the Agon Lite available. This is the original version. There's also a cost-reduced one made by Olimex. Now, the cost-reduced one was not available in the UK at the time that I bought this. Ironically, you could buy it and get it shipped anywhere in the world except for the UK. But it's now available from places like the Pi Hut and I think a few other places when they have stocks. So this one came to me as a kit. Basically all the surface mount parts are already attached and the through-hole soldering parts come in this nice little bag. Here we go. So our first job is going to be to put these on that. So I think we just work out basically where everything goes. So let's check out the Agon Lite. We've got it fully assembled now. The buzzer is the right way round, the caps are the right way round. This is correctly installed and the nylon washer is preventing it from short-circuiting. So I think it should be ready to try out. I've got a 32GB SD card in here. This has got the demo files that come from the GitHub. I'll put the link to the GitHub in the description. That has all the manuals, all the demo files, all the what have you. So VGA cable goes to the monitor. Keyboard here is a standard USB keyboard cheapo from Amazon. It's going through a USB to PS2 adapter into the PS2 connector. I don't have the sound plugged in at the moment. It should go through the buzzer. This little jumper here activates or deactivates the buzzer. These two jumpers are just set according to the default value in the manual, and I guess we should try it out. I have a USB cable which goes to my big USB power supply, and there's no on button, we just plug it in and hope it does something, or not, as the case may be. Welcome to some time later. I finally got this thing to work. There were several problems with it. First was that the USB lead was not up to snuff. This is basically the previous one. Some of you might well already know this, but not all USB cables are equal. And the cable that I was using on this was just not up to the job. I think it must have been a USB 0 or something. It didn't seem to be able to carry enough current to actually power this Agon light, and so I've got a much more recent USB cable. This is a USB 3 cable, and that is definitely up to the job. The second issue is that there's firmware on this board, and when I bought it, it said the MOS firmware is already programmed on there, which is a good thing because the cable to program that particular firmware costs more than the board does itself. It's about 100 quid or so. I mean, it is very expensive, and without it you can't program the firmware for that, and so fortunately that is already programmed. But the ESP32, which is the video coprocessor and if you like the sort of Arduino side of it, firmware was not programmed. And so there was no output from the video, and it did nothing. So I had to figure out how to program that, and I did all that off camera. And now it is all programmed and working, and you can see up on the screen we have VPD version 1.02, MOS version 1.02. Now that is not the latest. That was another saga, by the way. I programmed the VPD, but of course downloading the stuff from GitHub, it brought down the latest version, which was 1.03, and the 1.03 VPD firmware does not work with the 1.02 MOS firmware, and so that was another yada 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 yada. Anyhow, it's all working at the moment. It's at version 1.02. I do need to update it all to version 1.03, and we'll do that shortly. Meanwhile, we can't turn this on and have it running without doing our little Hello World program. And of course, if you've been around Commodore machines, you'll know that Hello World is not really Hello World, it's a little sort of mazy thing. And so we're going to write a little one-line mazy thing. So let's do that. Okay, so here we go. I got it wrong again. Yes, I see what I did. Too many open brackets. Not enough open brackets. Hurrah! Okay, after a few false starts, we get the program right. So now let's update the firmware. Okay, so we are going to update the firmware on this Agon light, and to do that we need to go to the wiki for the firmware, and you can see this is into break into program /Agon docs. GitHub. This is by Dean Belfield, who actually wrote all the firmware for it. So, upgrading from 1.02 to 1.03. So, prerequisites: we need a USB cable, a micro SD card, and a micro SD card adapter. Okay, so download the following components: MOS 1.03 binary. These are just direct links into the GitHub, so you can see the link there on the screen. It's always important to check a link before you click on it. And these will just download straight into our downloads folder. So now I'm back at the computer. I've put the SD card into the card slot, so we just need to power it on. Okay, now type *by in BBC Basic. That gets us out of BBC Basic. CD/ and then flash MOS.bin OX81E397C9. That's the checksum. And there it goes. Agon Quark MOS version 1.03. Excellent. Power it off. And now we go to the next bit. Back at the laptop yet again, and we insert the SD card. And this time we copy bbcbasic.bin to the root directory. So that's in downloads. Replace that file. That is done. The last part then is updating the VDP. So I've got the VDP source here inside a folder called video. Here we are. The Agon is plugged into COM3, or at least it's a USB that's masquerading as COM3. So let's start the IDE. Now you do not want to do an update because the Agon VDE relies on specific versions of libraries which are not the most recent ones. And if we allow it to update, then it's going to all go wrong. So, no. Right, ESP dev module on COM3, that is correct. And we say upload. It will compile the sketch and it will upload it. There we go, it's done. We should be able to go back to the other side of the room and plug it in and see it all working. So let's do that. So here we are. Let's apply power. And there we have it, 1.03. There we go, BBC Basic version 3, Quark VDP version 1.03, MOS version 1.03. Purely for the sake of running something in BASIC, it's kind of going off the side of the screen a little bit. We would need to adjust the screen for that, but I'm not gonna. So there we have it. Now you might be one of the 3 people that watched my LEDs video last time, and if you are, you'll know that LEDs are quite a little passion, and everybody loves watching the blinking lights. So you might also have seen at some point, because no doubt I've shown it various times, this test harness that I built for my PIEEE 488 project. And it's got 2 rows of bar charts on it, bar LEDs, and these basically are driven by the IEEE 488 signals. So I've got one in yellow, that is the data bus, and one in red, that is the control bus. And they each have a resistor, fairly standard sort of LED circuit. But the GPIO demo on the Agon light examples, I want to call it an examples disk, but the examples folder is one that actually drives one of these bar LEDs. And it's a binary counter, and I'll show it to you on the screen. It's called GPIO. And this was written by Bytatic, and he has in fact demonstrated this on his channel. So you can go and have a look at it there and see exactly the same thing. Now this is using the... Oops. Don't want that to fall out. This is using the GPIO pins. Now the GPIO is a general purpose I/O bus that has a number of 8-bit data ports that are directly driven off the Z80, and there's not much documentation in terms of driving it from BASIC other than this example program and the reference documentation for the Z80. Now this basically takes one of the 8-bit ports, which are these 8 pins here, 4 on the top, 4 on the bottom, and the ground pin here, and I'm driving this 10 bar LED bar display, but only driving 8 bits of it, so the 2 end ones I'm not driving. The signals from here come through this resistor pack. This is not a chip, this is a resistor pack, and I have to say I got the idea for this from Bytatic's video, because he used one of these, and it is a damn sight easier than trying to put these 1/4-inch resistors into this prototype block, because the legs keep falling out, they're very thin, they don't make very good contact. This is just like an IC, and it's perfect. It's 8 1K resistors basically across. The other end of that comes to these LEDs, and it goes through the LEDs and to ground. But anyway, we've got the listing here. Let's have a little look at the listing, and I'll sort of explain a little bit what this does. There are 4 variables that control the 3 ports, and we've got 2 of them here. So we have the B port and the C port, and of these 4 values, DR% here is the data register. This is the actual data that we're plugging into the port. DDR is the data direction register, and you set basically each bit in that either to a 0, which means it's an output, or a 1, which means it's an input. These addresses, by the way, they're in hex, but they are directly assigned in the I/O space of the Z80, so they are sort of hard-coded. So this program sets up all the GPIO on port C to output. It calls this proc res GPIO. That's this procedure down here. Basically, it puts values in the... you can see what it does. So I'm sort of making this up as I go along, or at least I'm sort of figuring this out as I go along. And then this is the meat of it. We go through for 0 to 255 and we increment this counter and we write that value to the data register. And then we just have a little loop timer here that basically puts a delay in there, and we go round and round and round and round. So that's essentially what it does, at least what I think it does. So I'm going to run this. So let's fire it off. And it's just going to go round and round and round. So I'm going to spend some time studying the GPIO port and figuring out how to program it, and hopefully I'll be able to show you some of the same LED demos that I showed you last time on an Arduino or on a Raspberry Pi, but actually programmed in BASIC on this Agon light. That'll be fun, won't it? That will be fun, won't it? Seriously, it will be fun. So, thank you for watching, those of you that have come this far, and everybody else, well, you're not watching, so you don't need to be thanked. Please like and subscribe and do all the YouTubey bits. We would like to get to 1,000 subscribers by sometime soon, and if you haven't subscribed, please subscribe. It does not cost you a penny. It helps the channel out. It gives me encouragement to do more of this stuff. Not that I need encouragement to do more of this stuff, but all the encouragement helps, and I am waffling, and so I will see you next time. See ya! Bye bye! Let me take it out of its wrapper. I'm going to start this again.